Good morning, good afternoon, good evening. Today I will be showing you how to make this Rollup Text Effect. As you might have guessed from the length of this video, creating this effect is more cumbersome than it seems. Well, how hard can it be, you might ask? To that I say, you might lose your mind if you try out a long phrase manually. So instead, we'll be making a geometry node to perform this task automatically. However, it is still going to be a long video, so proceed with caution. Alright, let's get into it. Alright, as soon as we get into Blender, we'll hop right into Geometry Nodes Layout, A to select all, X to delete. Shift A, add mesh plane. Using numpad 7 and 5, we'll go into Top Orthographic View, click on New, delete group input, replace it with string input. I'll type in something like dog, sheep, cow in here. It's just random words, it doesn't really mean anything. Go to strings to curve and output. Alright, I want to have the words in individual lines, so I'm going to use a replace string. Pop it in here. In the find section, I'm going to add a single space, like so, then replace it with a line break. Okay, so now they're all in different lines, but I'm going to actually squish it together by changing the line spacing to 0. Then I'm adding separate geometry, change the domain to instance, pull out a line from line, then use compare equals, then connect the result to selection. So now I can change the word by changing this B value. Right, next. Right now we have 4 separate instances, separate curve instances, so I'm gonna use a geometry to instance to combine it into one instance, like so. Then use a translate instance and bring the word down by -2 in Y direction. So this is going to be the starting position for the text effect. Alright, so I've prepared a separate video clip for explanation of this Rollup text effect. So I'm going to show that now and I'll catch you when it's done. So the Rollup effect that we'll be doing today behaves as shown. However, when you manually try to recreate this action, you'll find out it's harder than it appears. It almost looks like all you have to do is move up text, keyframe, join it with geometry on the left, then keyframe, rotate scale, and keyframe. The problem is, it is not possible to keyframe the operation of joining geometry. If you try doing it that way, you'll end up with massive amount of geometry that you have to manage and toggle visibility for animation. Instead, we will be using geometry nodes and make a finite state machine inside of it. There are a lot of aliases like state flow, state automaton, etc. But all you have to know for this tutorial is that it is a tool to execute tasks sequentially. So, if I break this text effect down into states, this is how it looks. We've got 3 states and we'll be managing 2 geometry along with line index. We'll call the red one new geo and blue one old geo. And S0 slides a new geo up to destination, then transition to S1. For S1, join the old with the new to make the next old geo, and bring the next word in as new geo, then transition to S2. For S2, rotate and scale this old geo, then transition to S0. We'll repeat these operations until words are used up. Alright, let's get back to the node tree. Alright. So, we will be making a finite state machine, right? It's going to be pretty simple. I am going to start with some boilerplate node structure. So, what I'm going to do is make some space here. I'm actually going to cut it, then use a simulation zone, and spread it out like so. Okay. Next, open up the side panel with N. Go to the node tab. I'm going to change this to state. The type is going to be integer. I'm gonna add a new socket. Call this new geo. This is gonna be a geometry. Next, I'll have old geo. And lastly, I'm gonna have a line index. And this is gonna be an integer. So we will be maintaining these 4 variables and updating each frame. Okay, so I'm gonna start off by adding a index switch. Change the type to integer, and I'm actually gonna rename this state controller. Right. So this is going to be the primary switch that will be controlling the state transitions. I'm going to need one more item, as in we need 3 states, so I'm just going to go here and add item. Then we have 3 states now. Okay, I'm going to connect it up like so. Then Shift D to duplicate. Change the type to geometry, and I'm gonna rename this to new geo result. I'm gonna connect it up like so, and select the new geo result. Control Shift D to duplicate, bring it down, and I'm gonna call this old geo result. Then connect it up. Control Shift D to duplicate, change it to integer, change the name to line index result, then connect it up. Okay, I'm just going to reroute so it's a little bit cleaner. Like so. Then going into the simulation input from the new geo, I'm going to connect it to 0. From old geo, connect it to 0 socket of old geo result. Then line index to 0 as well, like so. Okay. Using Shift right click drag, I'm gonna make a reroute node like this. Then I'm gonna Control G to make it into a group. Okay. Now I'm gonna delete these reroute nodes, and you can see it's kind of out of order. So on the side panel, I'll just reorder it. So it's going to be new geo, old geo, line index. Same thing with the input side. So it becomes straight like so. And matter of fact, I'm just going to rename the inputs as well. New geo, old geo, and line index. Okay. Right, tab back out to the top layer, and I'm gonna rename this guy exec S0. So this is the execution of S0 state. Select it, Control Shift D to duplicate with lines and bring it down. And click on this number so it becomes a single user, then rename it to exec S1. Control Shift D to duplicate, bring it down. Make it a single user and change it to S2. Okay. For exec S1, I'm going to connect it to the 1 socket of each new geo, old geo, and line index. And for S2, I'm going to connect it to the 2 socket of these switches. Alright, so this is pretty much the boilerplate state transition that I'm using. Basically, we have a straight controller that controls the transitions, and these are individual boxes control the execution operation within each state. Okay, so I'm just gonna initialize the values. So transition instance goes into new geo, and for the output, I want to combine new geo with old geo and plug it into group output like so. Okay, so let's go back to the original layout. You can see the dog is right here, sitting right here, right? Okay, so what I'm gonna do is start with S0. execution content of S0. So what do we want to do in S0? Well, this dog is going to be the new geometry. So I want to move the new geometry up to the original location of 0, right? So we've shifted the dog down by 2 units. We want to move it back up. So this is going to be the content of S0. So let's go back and implement this. What I'm going to do is just move this guy over here and duplicate the group input and connect the new geo to new geo. This is just to clarify that I'm only going to be tampering with the new geo, so these guys aren't, the old geo and line index is not going to be changed. So next I'm going to use a translate instance, and from translate instance translation use a combine XYZ, and I'm going to input 0.1 into Y. Okay, so if I were to run the animation, dog is gonna move up in Y direction, but you can see that it's not stopping. When you're using something like translate instance in simulation zone, this value that you put into it is going to be the rate of change per frame. So basically same as speed. So it's gonna be a little bit hard to say stop it at a position, right? But this is how I do it. There might be other ways, but this is a particular way that I like to do it. So I'm gonna insert a position node, then use a separate XYZ. Then from Y, I'm gonna use a subtract. With subtract selected, press Alt S to switch the top and bottom socket input. Then plug in a 0 in here. Then from the result, I'm going to use a minimum and plug in 0.1. Then plug it into Y, like so. Okay. And if I were to run the animation, the dog stops at where I want it to. Okay. This is a notation that I'm going to use a lot. The way I do it is I get a separate XYZ or a position and use a subtract, then use a minimum, then combine it. Well, what does this actually mean? Well, this subtracts value on the top is the target destination of where you want the geometry to be, right? So say for example, if I were to input 1 in here, it's going to stop at Y equals 1. Okay. So this is the target location or target destination, and this minimum, the value in the minimum is going to be the speed. So if I were to plug in 0.3, it's going to move much faster. If I were going to plug in 0.05, it's going to move much slower. Okay, but it will always stop at this target location. Okay, so this is, like I said, a notation I'm going to be using throughout this tutorial, so it's better if you could remember how it works. Okay. Right, so S0 is complete. Let's move on to transition condition from S0 to S1. So we want to transition from S0 and move on to S1. So how are we going to make this? Well, the transition condition is pretty simple, right? So we want to transition when the position of that new geometry of, well, specifically the Y position, right, is greater than equal to 0, right? So when it reaches 0, then we want to transition, and we want to make sure we sample it. Sample index using the value, and since we're working on instances, change the domain to instance, and we want to specify the geometry, which is a new geometry, right? Then we'll put it through a switch and change it into integer, and this is a state that we want to transition to. So if this condition is not fulfilled, we want to stay in state 0, and if it is fulfilled, we want to switch to state 1. Okay, so I'm gonna plug this into state controller of state 0. Right. So let's see how this works, and I'm just gonna plug in a viewer right here and change it to instance and see if it works correctly. Alright, so something's happening, but you can see it's flashing back and forth, and you can see the state right here is going kind of berserk between 1 and 0, right? The reason for it is because when we transition to state 1, it's automatically saying we want to transition back to state 0. So what I'm going to do is change this value to 1 and change this value to 2 so it doesn't automatically transition. So if I were to run it again, boom, you can see that it transitions to state 1 and stays there. Okay. So I'm gonna Control G and reorganize a bit. Okay. Alright. I'm gonna tab back out and call this judge trans from S0. Transition condition judgment from state 0. Let me just make a little bit of space. Pop it in here. Okay, so state 0 execution is complete, and also transition from S0 is complete. So next we want to work on S1, right? So what are we going to do with S1? The dog is here. Well, like I said, this is a new geometry, but right now it's not here yet because it's a first geometry, but during the animation there's going to be an old geometry that's located here, right? Old. Okay, so the first thing that we want to do in state 1 is combine this new geometry and old geometry and turn it into the next old geometry. Okay, so these two become old, and next we're gonna have the next word come in, which is sheep, and this is gonna be the new geometry, the next new geometry. Okay, so there's two operations, this part and this part. So let's start with this one, combining these two. This is going to be pretty simple. I'm just going to duplicate this group input. I'm going to use a join geometry, combine the new geo with old geo, then pass it through a geometry to instance node to make it into a one instance, then plug it into old geo like so, and that's all we have to do. Right? So for the next one, next part, which is bringing in this sheep and making it into our new geometry. Well, we have a slight problem here because the sheep is neither a part of new geo or old geo. Neither of them contains this sheep. So the first thing I have to do is go into the group tab and add two more socket inputs. Right? And for the top one, I'm going to call it original. And this is going to be a geometry input. And this is the next one is going to be a line. And this is going to be an integer. I'm going to tab back out. And I'm going to drag the lines from the strings to curve into the original. And this line into line. Well, you can kind of understand because the only place that we have the sheep is right here, right? Because after this part, we only have the dog. So this part contains all dog, sheep, and cow. So I'm gonna bring that in and get it in here. Right. So how are we gonna pick the sheep out? Well, we are gonna do the same thing that we did with the dog, but we have to increment line index before that. Okay, so I'm just going to duplicate this Line index right now is 0 because we are looking at dog now, and now we want it to point at sheep, which is 1. So from line index, I'm gonna pull out an add and add it together, add a 1 to it, just to increment. We also want to keep this in the state machine, so it's going to be updated every time it reaches state 1. So I'm going to pull it out like that. Okay. Right, now that we've incremented the line index, I'm just going to duplicate the group input. From original, use a separate geometry, and from point, change it into instance. And from line, pull out an equal, connect the selection, result to selection, and use the incremented line index and plug it into B, like so. Then from the selection of separate geometry, we'll do the same thing we did with the dog, so which is geometry to instance. Then translate instance, and translate it by -2 in y direction. Then we'll plug it into new geo. And with this, I'm not going to need the group input right here. So I'm just going to line it up a little bit. Okay. It's a bit clean. Okay. Alright, so let's run the animation. So if I were to run the animation, well, something happened, right? You see some weird thing going on. So right here we got the dog, then sheep comes in, then cow comes in, then dog disappears, and sheep disappears, and some weird things going on. The reason for this is that for state 1, once we do this execution of state 1, we want to automatically transition to state 2 because we don't want to keep on doing state 1 again. So I'm just going to increment this by 1 and make it into 2. So if I go in and run the animation again, it's going to be dog, sheep, and boom, it's not going to be changing, right? And also the state right now, we're looking at state 2. Okay, so we've pretty much finished the state 1 and transition condition from state 1, which is automatically transition to state 2. So let's move on to state 2. Okay. Right, so what do we want to do with state 2? Well, there's 2 operations that we want to do, right? So we got the old geometry, and we want to get this dog and rotate it this way by 90 degrees and shrink it so it matches the size of the next word, right? If you rotate it, it's going to be kind of coming up to the top, but we want to shrink it down. So let's work on that. Go into state 2 execution. I'm just going to duplicate the group input. And since we're working with the old geo now, plug in the old geo to old geo. And let's get working on it, right? So we'll start with rotation. I'm going to use a rotate instance and pull out a combine XYZ from rotation. And if I were to plug in something like 0.1 into Z, what's going to happen is the dog is going to rotate, and it's going to rotate forever. Just like what we did with state 1, state 0 actually, we want to stop it at 90 degrees. So I'm going to use a similar notation. Instead, this time I'm going to use an instance rotation and pull out a separate XYZ. From the Z, I'm going to use subtract. And I'm going to switch the top and bottom input. And this time, because we want to stop it at 90 degrees, it's going to be pi over 2 radians, the target destination. Then use a minimum, and I'm going to use a 0.1 radians per frame, then plug it into Z, like so. Okay. So now boom, it stops at 90 degrees. Great. Okay. Next, what I want to do is shrink it. Well, scale it down, right? How do we want to scale it down? Well, I want the dog height right now to match the sheep height right here. But the problem is during this state, we basically are rotating, so we don't really know how much we have to shrink it by, right? During its rotation, the XY size is constantly changing, so we don't really want to calculate how much we scale it by at this point. Instead, what I want to do is go back to state 1 and calculate at this point how much we have to scale it down by, right? Because right now it's static, it's easier to calculate. Okay, so what I'm going to do is hop right out and go back into state 1 execution. Okay, so at this point we can calculate how much we have to shrink this dog by. So we want to match the height of sheep, which is pretty much this part. And one thing to note is I don't really want to include this part, which is below the x-axis. This part is going to be below the x-axis, right? So I don't want to count this part. I only want to calculate this part for the sheep height. And also we want to make sure that this length matches this height, right? But just to remind everyone, there is going to be also an old geometry right here, kind of stuck here. So it's actually going to be this length that is going to have to match with this height. Okay. All right. So let's calculate that. Starting with the sheep part, I'm going to pull out a realize instance from this geometry to instance, then get a bounding box. And I'm just gonna separate that out. And this part is gonna be actually a separate geometry, separate XYZ Y coordinate. Okay, this Y is gonna be the height right here. Okay, so next, let's get this length, which is gonna be realize instance, same as before. Get a bounding box. Now for this one, I'm going to use a vector mass. Change the add to subtract. Subtract min from max. Then use a separate XYZ. And this X is going to be this length of this dog. Okay. So now what I need to do is grab this Y and divide it by this X to get the final scale that we want the dog to shrink to. Okay. Next, I'm going to use a store named attribute and change the domain to instance. And I'm just going to call this end scale. Then plug the result of this divide into the value, like so. Just going to move it around a bit. Okay, so now the state 1 calculation or execution is going to kind of look like this, right? With this new end scale calculation. I'm going to hop right out, go back into exec_s2, make a space after rotate instance, and I'm going to scale instance next, right? I'm going to grab the named attribute that we just made and scale, then pull out an instance scale. And since this is vector, I'm going to just use a separate XYZ and pull out a single axis. Since it doesn't, I'm going to scale it uniformly. It doesn't really matter which axis I'm going to use, but I'm going to divide this named attribute and scale by x-axis. Then use a max or min, or I'm gonna start with max then. Max, and I'm gonna max it by 0.9. Right. Then I'm gonna use a minimum, and minimum it by 1.1. Then plug it into scale like so. Okay. So now if I were to run the animation, you can see the dog shrinks, and it's now matching the height of sheep right here. This height and this height is matching. Alright, great. So we're kind of done with S2, so let's hop back out and make the transition condition from S2 to S0. Well, how do we want to make that? Well, kind of similar to transition from S0, right? So what we want to first compare is get the instance, rotation, and separate XYZ. Grab the Z and make sure it's greater than or equal to pi over 2, which is 90 degrees. And also we want to make sure that instance scale, and we'll separate this out by XYZ. We'll grab this X and make sure that it is equal to or within an epsilon of named attribute and scale, right? If these conditions are fulfilled, which means we want to make sure it's and, we'll and it together, and in which geometry, so we'll have to sample index, plug it into value, and from point make sure it's instance, and we want to make sure that's happening on old geo, right? So we'll plug in old geo into geometry, then use a switch, change it to integer, and if this is not fulfilled, what we want to do is stay in S2, and if it is fulfilled, we want to transition to S0. So we'll grab the output and plug it into state controller S2 socket, like so. So if I were to run the animation right now, you see the dog, then sheep moves, then the cow goes, okay? And the transition looks like it's going, everything's looping. So I'm gonna control G, these nodes, and reorganize it a bit. Hop right out and call this judge trans from S2. Alright, great. So everything seems to be working, but I'm just gonna make a little change in S1. So this is gonna loop forever. You don't really have to do this, but I want to kind of show a point. So after this group input addition of 1, I'm gonna create a little space right here and expand this group input. From original, I'm gonna pull out an attribute statistic and connect the line into the attribute and change the domain to instance. From max, I'm going to use an add and add 1. Then from the top add, I'm going to use the floored module and connect the bottom add to the bottom. Okay. Right. Then I'm going to get the result and connect it to the reroute right here. Okay. So now it's going to loop forever. Dog, sheep, cow. Dog, sheep, cow. Alright. There is one point that I want to address, or one part that I am not really a fan of, which is right here, right? You can kind of see that this dog is sticking out like so, and this P is sticking out like so, right? So it's kind of like that. Ultimately, what I want to happen is everything to be, well, all the old geometry to be settling in this quadrant. So this quadrant. So what I want to do is shift these guys up like so, right? So it's not going to be pointing out in this direction nor in this direction. So in order to do that, basically in state 1, which is right here, I want to calculate the position that I have to shift these guys as, right? So same thing that I did with the scaling part, I'm going to calculate how much position I have to offset it by, right? So right now I'm in state 1. Just going to make a space here and going to duplicate this store named attribute, change it into vector. Then I'm going to call this end pause, right? Next, I'm going to pull out a line from this minimum, get a separate XYZ. And from the X, I'm going to use a multiply and multiply X by -1, -1, then combine it into Y. So X gets multiplied by -1, then goes into Y. Then I'm going to grab the Y and plug it into X. The reason for it is when we rotate it, basically we want to shift up. Well, we want to shift up this part, right? So we want to make sure the dog goes up. Then for the Y part, we want to shift it to the left. Okay. Then I'm going to use a scale, vector mass scale, and whatever that goes into this end scale, I'm going to scale it by this part. Okay. So it's going to connect it like so. Right, then I'm going to plug this into end pause right here. Okay. Tab back out, go back into S2. I'm going to make a little bit of space here and go add a translate instance. And make sure to click off this local space right here. Bring out the named attribute end pause, which was a vector. So end pause and grab a position node. Use a vector mass subtract and subtract position from end pause. Then use a vector mass max and max it by -0.05. Then use a vector mass min and minimum it by 0.05. It looks a little bit different, but it's pretty much the same notation as this guy, right? I'm just using vector mass entirely. Okay, then I'm going to put it into translation. And now, if I were to run the animation, you can see the dog shifts over so it fits in this quadrant, right? So nothing sticks out in the bottom or on the right. I can increase the frame. Right? Dog, sheep, cow. Dog, sheep, cow. Right. Last thing I want to address before we go to wrap up is basically there is a limit right now to how much we can stack on top. So what I mean by that is basically if I were, say if we want to look at this dog, right? So just follow this dog, sheep. We have the dog right there. We have the dog right there, right? But as soon as this sheep comes in, you can see the dog suddenly disappearing. I'm not quite certain why this happens, but My speculation is when we do join geometry, which gets stacked, which that instance gets stacked, there is a depth limit to how much stacking we can do it on an instance. So if you want to keep that dog or keep the old instance there, what you can do is realize instance on top of this old geo. And if we do the same thing, just follow the dog, sheep, cow, dog, sheep, cow, and you can see that the dog is still there, right? No matter how much, how deep we go, the dog is still gonna be there. Okay. It is possible to do this, and if you want to do like something like a infinite zooming animation, it's probably important to have these in here. But since it's going to be really small anyways, you're not going to be able to view it if you're just looking at it from this side. So my preference is to not keep it in there, because it's gonna end up with a lot of memory wasted. So yeah, it's up to you, but if you want to keep it, pop this realize instance in here. Okay. All right, great. So we're pretty much done. Let's review what we made. So today I've kind of introduced how to implement a state machine through the use of Rollup Text. So this is a boilerplate state machine structure that I use for geometry nodes. Pretty simple. We have the state controller, which has the transition conditions, and we have separate boxes for each execution of state. Okay. We'll go into individual boxes. This is a transition condition from state 0 to state 1. This is a transition condition from state 2 to state 0. The content of S0. Content of S1. It's a little big, but let me kind of shrink it down. There's basically 4 parts to it. The part that updates the index, the part that brings in the new geometry, the part that brings in the old geometry, and this part is creating some information for state 2. Okay. I'm going to zoom in a little bit for a better view. Right. And this is the content of S2, where we do the rotation, scaling, and translation. Okay. Right. As I explained in the short video, the state machine has a lot of usage outside of, text animation. Pretty much all devices that we use daily has some form of state machine in it. Game engines use it. It's not really a computer graphics thing, but yeah, this is kind of how you can implement a state machine in Geometry Node. It's useful, so I hope you get to use it, and I hope to see you next time.